In lesson 9.7, we learn how to compare decimals. So in our first problem here, it says the city park covers 64 hundredths square mile. About 18 hundredths of the park is covered by water, and about 2/10 of the park is covered by paved walkways. Is more of the park covered by water or paved walkways? So over here it gives us a box of little tips of things that we can do before we solve the problem. So first it says cross out unnecessary information, and then circle the numbers you will use. So we know that we are comparing if there's more of the parkway covered with water or paved walkways. So we know we're going to need the 18 hundredths covered by water, and we know we're going to need 2/10 covered by paved walkways. But this first number here, the city park covers 64 hundredths square mile, is unnecessary for this problem. We do not need those numbers to be able to solve this problem. So one way that they want us to compare this is to first use a model. So we have to shade 18 hundredths. So I'm going to shade 18 of these 100 boxes here. And then they want us to shade 2/10. So I'm going to shade 2 of these sections here. And by looking at these two models, we can tell that 2/10 is greater than 18 hundredths because we have more of this model shaded, since this one is only broken into 10 parts and this one's broken into 100 equal parts. So another way we could compare these decimals is to use a number line. So first they want us to locate 18 hundredths on the number line. So we know that this is 20 hundredths, so 18 hundredths is going to have to be 2 spaces less. And then 20/10. Well, we know if we're thinking about 20/10 in terms of hundredths, that would change to 0.20. So 20/10 is actually on this number line, or sorry, 20 hundredths is on this number line equal to 2/10. So we know that 18 hundredths is closer to 0, so that means that 18 hundredths is less than 2/10. And the final way that they want us to compare is to compare equal size parts. So we know that 0.18 is 18 hundredths, and we know that 0.2 is 2/10, which we also know is equivalent to 20 hundredths because we'd have to multiply this by 10. So 18 hundredths we know is less than 20 hundredths, so 0.18 would be less than 0.2. So more of the park is covered by paved walkways. In the next problem, we have so place value appears as you can compare numbers written as decimals by using place value. Comparing decimals is like comparing whole numbers. You always compare the greatest place value position first. So in our chart here, we know that ones is the greatest because those are the whole numbers, and anything after the decimal represents a fraction. But if we were thinking just in terms of tenths and hundredths, the one closest to the decimal is always greater. So tenths is always going to be greater than if we have anything to the hundredths place, as long as the tenths number is bigger than what's in the hundredths number. So our problem here says Tim has 5/10 of a dollar and Sienna has 5/100 of a dollar, and we have to figure out who has more money. So if we're going to shade the model here broken into 10 equal parts for Tim, we have to shade 5 of these 10 boxes. And if we're going to shade 5/100 of a dollar, we have to shade 5 of these 100 boxes. So we know that by looking at the models, we know that Tim is going to have more money because 5/10 is greater than 5/100. And if we're going to compare these using the decimal place, so we know Tim has to be on top, and we have 5/10 of a dollar, so 0.5. And Sienna has 5/100, so 0.05. So we first can start by just looking at the tenths place. We don't even have to worry about the hundreds right now. We know that Tim has more money because 5 is greater than 0. If both of these numbers were the same, then we would move to the hundredths place to compare. So the digits in the ones place are the same. Compare the digits then in the tenths place. And if those were the same, we would then compare in the hundredths place. So 5/10 is greater than 0/10. So 0.5 is greater than 0.05. So in our next problem here, number 1, we are going to compare 39 hundredths and 42 hundredths, and then we have to write the appropriate sign there. So first we're going to shade our model for 39 hundredths. And then we're going to shade our model for 42 hundredths. So just using the models, we can tell that 42 hundredths is greater than 39 hundredths. And here they want us to compare using the place value chart. So if we have 26 hundredths and 23 hundredths, so to write 26 hundredths, we'd write 0.26, and to write 23 hundredths, we would write 0.23. So we're looking at the ones place, they're both the same, so we have to move to the next greatest value, which would be the tenths place. As I said earlier, both of these numbers are the same, so since both of these numbers are the same in the tenths place, we then move to the next greatest value, which is the hundredths place. Here we can see that 6 is greater than 3, so that means 26 hundredths is greater than 23 hundredths. We'll also give number 3 a try here. So we have 7/10 and 54 hundredths. So if we are writing 7/10 in our place value chart, we'd write 0.7. And then if we're writing 54 hundredths, it would be 0.54. So again, we start in our ones place. They're both the same number, so we have to go to the next greatest value, which would be our tenths place. Here we have different numbers, so we can go ahead and compare right away. We know that 7 is greater than 5, so that means that 7/10 is greater than. As we're looking at the next set of problems here, they just want us to simply write the greater than, less than, or equal to sign. So if we're looking at 9/10 and 81 hundredths, our zeros are the same for the whole number, so our next place to look at is the tenths place. We can see right away that 9 is greater than 8, so that means 9/10 is going to be greater than 81 hundredths. Looking at number 7, looking at the whole number first, so we have a 0 and a 1, so we know right away that 1 and 6 hundredths is going to be greater than 6/10. Looking at 25 hundredths and 3/10, 0 is the same, so we go to the tenths place. 3 is greater than 2, so that means 3/10 is greater than 25 hundredths. And for number 9, we have a 2 and a 3 as our whole numbers, so 3 is greater than 2, meaning that 2 and 61 hundredths is less than 3 and 29 hundredths. And the next set of problems, they have one fraction comparing to one decimal. So you can change the decimal into a fraction, or you can change the fraction into a decimal to help you make it easier. So I know that 30 hundredths is the same as 30 over 100. And then if I change this into a denominator of 100, I have to multiply by 10, and I would get 30 over 100. So these two are equal. Here we have 2 tenths, which is equal to 20 hundredths. We know that 20 is greater than 4, so 2 tenths is greater than 4 hundredths. Here, if we would change this into a denominator of 100, that would be 10 hundredths, and we have 15 hundredths here, so 15 hundredths is greater. And here we have 1/8 and 8 tenths. If we were thinking about 1/8, that's not a denominator of 10 or 100 like we've been used to. So we would have to think about 1/8 as a fraction compared to 8 tenths as a fraction. And to help us do that, we can turn this one into a fraction. So it'd be 8 tenths. And then we can make a common denominator here. So if I multiply the top and bottom by 10, that would give us 10 over 80. And then I'd have to multiply by 8 here which would 8 times 8 is 64, 10 times 8 is 80. So just making a common denominator. And I know that 64 eightieths is greater than 10 eightieths. So that means 8 tenths is greater than 1/8. And looking at number 16, the Venus flytrap closes in 3/10 second and the water wheel plant closes in 2/10 of a second. What decimal is halfway between 2/10 and 3/10? So, and then they want us to explain our answer. So, looking at, if we were to make a number line here, and this, let's just say, was 2/10, this one was 3/10, we can look at these as hundredths as well to make it easier, because in between our 2/10 and 3/10 we have another 10 equal spaces. So these are our bigger ones. So we need to know, what is the halfway point here? So if we make this hundredths, so 20 hundredths, and we make 3/10 30 hundredths, we know we can just add our 0 to those. So looking at the halfway point between 20 hundredths and 30 hundredths, we can think about just the numbers 20 and 30. So we know that halfway between 20 and 30 is 25, meaning the halfway point between both of these would be 25 hundredths. And our, oops, that's not 25 hundredths. And our explanation for this would be using a number line, that 2/10 is equivalent to 20 hundredths, and 3/10 is equivalent to 30 hundredths. So halfway between is 25 hundredths, or 0.25.